Hello students, today we are going to discuss 10th Science A, second chapter periodic classification of elements. This is lecture number 5. So today we are going to study the properties of elements in periods and groups. So in previous lecture we studied about the modern periodic table. Now we have to study the properties of elements in periods and groups. Now we know the period, what is period and what is group. So periods are the horizontal rows and total number of periods in modern periodic table are 7. Groups are the vertical columns and total groups in the periodic table are 18. Now the properties of these groups and period. So the first property is valence electrons. Now what is meant by valence electron? Suppose there is any atom, that atom contain nucleus and around the nucleus there are different shells. Suppose this is center, at center there is nucleus, around the nucleus this is first shell, then second shell, like this. So valence electron is the number of electron that present in the outermost shell. So in this example here outermost shell is the second shell, and if there is one electron in the outermost shell then the valence electrons are 1. If electrons are 3 then valence electrons are 3. If third shell is present then the number of electrons present in the third shell are the valence electrons. Okay, so this is about valence electrons. Then see the topic valence electrons. In a period the number of valence electrons increases from 1 to 8 from left to right, and number of shells is same. Now we have to study this concept valence electron across the period and across the group. We have seen the periodic table also. So this is periodic table. This left to right, these are the groups, and from top to bottom this is period. Okay, now in groups and period valence electrons. So in period number of valence electron increases in period, that is from left to right, from 1 to 8. So at the left side in first group there is one valence electron, and as we move to the right side the valence electrons are 8. Example is given for second period. So in second period elements are these one: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. We can see in periodic table also. This is second period and these are the elements: lithium, beryllium, here boron, carbon, nitrogen, oxygen, fluorine and neon. So as we move from left to right, here for lithium valence electron is 1, for beryllium valence electron is 2, for boron it is 3, 4, 5, 6, 7, and for last one neon, that is 8. So how this? Because the elements in this second period have atomic numbers. So we can see here lithium have atomic number, this An is atomic number. So lithium has atomic number 3. That atomic number is nothing but we studied in previous lectures. Atomic number is number of protons or number of electrons is atomic number. So as atomic number is 3, protons are 3 and electrons are 3. Now the shells that present around the nucleus have the capacity. Suppose this is nucleus and these are shells: first shell, second shell, third shell, like this. So these shells have electron capacity: first shell, second shell, third, fourth. So first shell has maximum electron capacity 2, second shell has maximum electron capacity 8, third again 8, fourth has 18. So this is electron capacity for the shells. Now see the first example, lithium. So lithium has total electrons 3. So we can draw this atomic structure of lithium. This is nucleus, and around nucleus there are shell. This is first shell. Now in first shell, we know in first shell maximum electrons are 2. In second maximum electrons are 8. In third also 8, and 4 18. So here in first shell there are 2 electrons, so this 1 electron and second electron, but lithium has 3 electrons, so we have to draw one more shell, that is second shell, and this second shell contain remaining electron, this 2, and remaining 1 electron in the second shell. Now this second shell is the outer shell for this lithium, and this outer shell contain 1 electron, and therefore valence electron for lithium is 1. And see this number of shells are 2. This is first shell and second shell. So number of shells 2, valence electron 1, because 1 electron is present in the second shell. So this is about lithium. Then next is the beryllium. Beryllium have atomic number 4. So structure will be like this: nucleus, first shell. Now first shell contain how many electrons? 2 electrons. So these are 2 electrons in first shell. So remaining 2 electrons, so that remaining 2 electrons are present in second shell, and as this is outer shell, number of electrons are 2, so these are valence electrons. So valence electrons are 2 for beryllium, and number of shells again 2, this is 1 and 2. Okay, then next example, boron. Boron have atomic number 5. So nucleus, first shell contain 2 electrons, second shell, now remaining electrons, so 2, and here total electrons are 5, so plus 3 electrons in the outer shell, so valence electrons are 3, and number of shells are same, again 2 shells. So we can check all elements. So for neon, the first shell and second shell, in first shell 2 electrons, and neon has atomic number here 10, so total electrons are 10. So in first shell there are 2, so in second shell there will be total 8 electrons, so this 3, then 4, 5, 6, 7 and 8 electrons. So these 8 electrons are the valence electrons, and number of shells 2 shells. Okay, so this is about valence electron in periods. So in period, number of valence electron increases from 1 to 8. Here for lithium, valence electron is 1, and for neon, valence electrons are 8. And the number of shells is same. Number of shells we can see for all elements, number of shell is 2. For period number period number second, this is for period number second. Okay, then in case of group, valence electron in case of group, so in a group number of valence electrons is same for all elements, but the number of shell increases from top to bottom. Now we have to take example of group. For example, in periodic table, we can take a group. This is first group, then this is last 18 group. We can take any one group, total group. So this hydrogen, from hydrogen to this francium, or we can take any group, suppose this boron to here last one. So in this group the valence electrons remain same, and but number of shells increases. In period we see valence electrons increases and number of shells are same. In case of group, valence electrons are same and number of shells increases one by one. So take the example. So see here example is taken, group number 1. So in group number 1, elements are hydrogen, lithium, sodium, potassium. So we can check again periodic table. So this is group number 1. and elements are here: hydrogen, lithium, sodium, potassium. Next are rubidium, cesium, francium. So atomic number of hydrogen 1, atomic number of lithium 3, atomic number of sodium 11, atomic number of potassium is 19. Now electronic configuration, as we know, first shell contain 2 maximum, second shell contain 8, third shell contain how much? 8, and fourth contain 18. So atomic number of hydrogen is 1, so we can draw the structure of hydrogen. This is nucleus of hydrogen, and this is first shell, and in first shell there is 1 electron because total number of electrons are 1. Then sodium, so for sodium we can draw structure, nucleus, sorry, lithium is there second. So for lithium, nucleus, first shell. Now we know in first shell number of electrons, maximum number of electrons are 2, so we can draw here 2 electrons in first shell. Now total electrons for lithium are 3, so we have to draw one more shell, and that shell contain 1 electron. Okay, so this is for lithium, this is for hydrogen. Then for sodium we can draw structure, nucleus, first shell contain 2 electrons, so these 2 electrons. Then total electrons for sodium now 11, so this 2. Then second shell contain, we know maximum electrons how much? 8, so there will be 8 electrons in the second shell, 3, 4, 5, 6, 7 and 8, and 2 from first, so 8 plus 2 become 10, remaining 1 electron, so remaining 1 electron will be in the third shell, so in third shell there is 1 electron, so this is for sodium. So from this we can see for hydrogen number of shells are 1, here shell is 1, for lithium shells are 2, for sodium shells are 3. So as we move down again, next element is potassium, so for potassium number of shells will be 4 shells. So as we move down in the group, the number of shells increases. And now see the valence electron. So in outermost shell there is 1 electron for hydrogen, so valency of hydrogen is 1. For lithium, outermost shell contain 1 electron, so lithium, valency of lithium is also 1. In case of sodium, see the outermost shell, this third one, so third one contain only 1 electron, so sodium has also valency 1. So valency is same, but shells are different. For hydrogen shell is 1, lithium 2, sodium 3, and valence electrons are same. So from this we can say in a group number of valence electrons is same for all elements, but number of shells increases from top to bottom. For hydrogen number of shell is 1, for lithium number of shell 2, sodium 3, potassium 4. Okay, so this is about valence electrons in periods and in groups. Then next property, second property is valency. Now say what is valency? In a period the valency of element increases from 1 to 4 and then decreases from 4 to 0 from left to right. Example is second period. Now first see what is meant by valency. So valency is the number of electrons that either donated or either accepted by the atom to complete its octet. Now what is meant by octet? So if this is nucleus and these are the shells, first shell and second shell. Now every atom try to make 8 electron in its outer shell. Suppose this is second shell, so every atom or element try to maintain 8 electron in the last shell, and therefore that atom either donate electron or either accept electron from other atom. So that number of donated or number of accepted electrons is called as the valency. Now check the example. So first example Group period number second. Elements are lithium, beryllium, boron, carbon, nitrogen. Same. Then atomic numbers we have seen. Then electronic configuration. Now we know that electronic configuration 2 1. That 2 1 indicate the first shell contain 2 electrons and second shell contain 1 electron. So this is 2 1. For beryllium 2 2, that is first shell contain 2, second shell contain 2. Boron 2 3, carbon 2 4, like that. Now for lithium, we can see here all elements. So see the last element, neon. Now in case of neon, what will be structure of neon? So for neon, atomic number, that is total electrons are 10. So this is nucleus, first shell, second shell. Okay. Now in second shell there are two electrons. We know cell capacity. So 2 electrons in second shell, and in first shell. Now in second shell, remaining electrons, so total electrons are 10. In first shell there are 2, so remaining 8 electrons are in the second shell. And what is meant by valency? So atom try to maintain 8 electrons. So in case of neon, there is already 8 electrons in the second shell, therefore he does not accept electron or does not donate electron. Therefore valency of neon is 0. Okay, valency of electron is 0 because neon has already 8 electrons in the outermost shell. Now take example of this element, that is fluorine. Now see what is about fluorine. Fluorine has 9 electrons. So this is structure for fluorine. Nucleus, first shell containing 2 electrons because first shell has capacity 2, second shell has capacity 8. Now second shell. Now atomic number or electrons are 9. So 2 here. So remaining 7 electrons in the second shell. So this second shell contain total electrons 7. Now atom try to maintain 8 electrons. So for maintaining 8 electrons, here 7 electrons are present in second shell or outer shell. This fluorine accept 1 electron. Okay, so he accept 1 electron from other atom and make total electron in the outer shell 8 electrons. So he needs how much electrons? 1 electron, because he already have 7 plus 1, it become 8. So this 1 is the valency of fluorine. Accepted electron 1, so that accepted electron is the valency. So for fluorine, valency is 1. Then check one more example, fluorine. Next to fluorine is oxygen. Oxygen has atomic number 8, that is electrons are 8. So nucleus, first shell contain 2 electrons. Now second shell. Now 2 in the first, 2 electrons in first shell. So remaining 6 electrons in the second shell. Now if he try to make 8 electrons, so he must add or accept 2 electrons from other atom. So 2 electrons accepted from other and total electron become 8, and therefore this 2 accepted electrons, the valency of oxygen is 2. So like this is valency. Then if electrons are less than 4, electron needed are less than 4, then he accept electrons. But if electrons are requirement is more, then in spite of accepting electron, it donate electron. Now see the example here, example of boron. Now boron has atomic number 5. So structure will be like this: nucleus, first shell contain 2 electrons, second shell, now 2 plus 3, so second shell contain 3 electrons. Now here for making 8 electron in the outermost shell, he has to accept 5 electrons, but he cannot accept 5 electrons because number is greater. So he donate these 3 electrons. So if he donate these 3, then outer shell become this first one, and this first one contain total 2 electrons. So valency is uh, the number of electrons to maintain either octet or duplet, that is either in last cell either 8 electrons or 2 electrons. So here if he donate 3 electrons, then outer shell contain 2 electrons and he complete his duplet, and therefore he donate these 3 electrons, so valency is 3. Okay, so this is concept of valency in the period. Now second topic is in the group. So in a group, valency is the same for all elements of the group. Now in a group, valency is same for all elements. Example is first group. In first group, elements are hydrogen, lithium, sodium, potassium. Okay. Now see the electronic configuration. Atomic number, this 1 for hydrogen, 3 for lithium, for sodium 11, for potassium 19. Then electronic configuration is this one. For potassium, atomic number 19, so first shell contain 2, second contain 8, third contain 8 and fourth contain 18. So for 19, first shell will contain 2, second will contain 8, third has maximum capacity 8. So total electron become 8 plus 8 16 and plus 2 18. But atomic number is 19, so one more needed, so one electron in the fourth shell. So this is electronic configuration for potassium. Then we can see the last electron in the last shell is 1. Okay, so that one electron is donated by every atom, and therefore valency of each element is 1, because here we can see last shell contain one electron for each, and that electron is donated, so that inner shell contain 8 electrons here for potassium, for sodium 8, and for lithium it become 2. So either completed duplet or octet. So donated electrons are 1, and therefore valency is 1 for all the atoms or elements in a same group. So this is about valency, concept of valency or property of valency. Then third property is the atomic size or atomic radius. So in period, atomic size of element decreases from left to right. So as we move from left to right, atomic size decreases in period, and in case of group, the atomic size increases in the group from top to bottom. And we studied that in group the one shell increases. For first group there are one shell, for second group second period there are 2 shells, for third there are 3, like that. So one shell increases, therefore size also increases. We can see in this diagram. So here for hydrogen, see the size of hydrogen is very small. Lithium is greater than, sodium is greater, again potassium is greater than sodium, rubidium is greater than potassium, cesium is greater than rubidium, because number of shells for hydrogen 1, lithium 2, sodium 3, potassium 4, 5, 6, like that. So as shell increases, size also increases down the group or top to bottom. And opposite to this, from left to right, we can see size goes on decreasing. Okay, so this is about atomic size in period and groups. And fourth property is metallic property. So if we observe the periodic table, we found that towards the left side of periodic table there are metals, and towards the right side there are non-metals. So metallic character from left to right decreases, because left side contain metal and right side contain non-metals. In group, from top to bottom, at the top there are non-metals and at the bottom there are metals. So metallic character increases down the group. Okay, Here we can see the example, group number 6. So group number 6 elements are this one: carbon, silicon, germanium, tin and lead. So carbon is non-metal, silicon, germanium metalloid, tin and lead are metal. So metallic character increases down the group and left to right decreases. So this is about metallic character. And last property is the non-metallic character. So non-metallic character is opposite to this, because to the left side there are metals and to the right side there are non-metal. So non-metallic character increases, and in the group top elements are non-metals and bottom elements are metals. So non-metallic character decreases in the group. So these are 4 properties of periodic table. We discuss about this. So here we complete the second chapter, periodic classification of element. So this is complete chapter, second chapter, periodic classification of elements. So thus we completed this chapter. In next lecture we'll study the next topic or new topic. Okay, thank you.